That the inner lining of the trachea is made up of pseudo-stratified ciliated columnar epithelium. Right? It's got those hairs of cilia on it that waft and clean out the mucus of dirt and debris within the air that you breathe. The lungs sit in the pleural cavity. The outside of the lung is covered by a membrane called the visceral pleura, and the inside of the rib cage is covered by a membrane called the parietal pleura. Okay, and then the space in between is the pleural cavity. The base sits on top of the diaphragm. In this model here, this purple is the diaphragm. So right here, you see the diaphragm curving up underneath. This is the base of each lung. The apex is at the opposite end of, if you remember the heart, the apex is the point at the end. In the lung, the apex is the point at the top of the lung, of each lung. So this is the apex of the right lung, this is the apex of the left lung. The costal surface is the portion that lies underneath the ribs. Right, it's curved, it follows the curvature of the ribs. This is the costal surface. If you think of intercostal muscles, costal cartilage, that refers to ribs, the rib cage. This is the costal surface, and then the medial surface is the mediastinal surface. The mediastinal cavities lie between the lungs. The hilus, just like we saw with, or the equivalent of the hilum of the lymph node, is the point at which the trachea enters the lung, the pulmonary artery enters the lung, and where the pulmonary vein comes out of the lung. Okay, so this point right here, it's not on the point at which the trachea basically enters the lung is the hilus. The fissures have already hinted towards. The right lung has a horizontal fissure. It's not exactly horizontal, but it's more horizontal than it is oblique. Right? So we've got a horizontal separating the superior from the middle lobe of the right lung, and then we've got a oblique fissure here, and big long oblique fissure here, separating the superior and inferior lobes of the left lung. The trachea would be the trunk of the tree. All of these blue features are rings of hyaline cartilage, right? You see in the trachea. And then it splits into two primary bronchi, right? Two primary bronchi. Each one of those goes into one of the right or left lung. The left lung has two lobes, two separated structures, and you can see how that is divided here by this oblique fissure. Got a superior and inferior lobe. The right lung has three lobes, superior, a middle, and a inferior lobe, separated again by two fissures. Right? The other reason they're asymmetrical is because the heart sits, behind the left lung mostly. So the next branches off of the primary. I can turn the right one around now. The next branches off of the primary bronchi are the lobar bronchi, and those are, you can see those on page 68, as the lobar bronchi, also known as secondary bronchi. So each secondary bronchus feeds one lobe of each lung, which would mean that there are three secondary bronchi on the right lung and two secondary bronchi in the left lung. And then they divide into tertiary, quaternary, all the way until they get smaller and smaller and turn into bronchioles. And we define a bronchiole as an air passageway that no longer has cartilage around the outside. All of the bronchi and some of the smaller bronchi have rings or plates of cartilage, which are these blue features on this model. And once we get to the bronchiole level, we no longer have cartilage. That's the differentiation in terminology between a bronchus and a bronchiole. Term, and I don't like calling it a structure because it's not a physical structure, it's a space. So if I pull on this cord, it's going to twist these cartilage structures and it's going to open the vocal cords, right? So you see that opening right there. So that opening, that space that appears between the vocal cords is the glottis. Right? It's a passageway. The epiglottis then is this elastic cartilage structure that covers over the opening to the trachea. You can also see we have a sagittally cut larynx here. You can see that this is the epiglottis here that would bend over and cover over the entryway to the larynx. All right, then we have 4 distinctive cartilaginous structures. Just to mention, it's not on the list, but this is the hyoid bone right here. Just familiarized. Feel it right up there under your mandible. We've got 4 main cartilaginous structures. The thyroid cartilage are these big pieces of cartilage here. All right, this protuberance is what results in the male Adam's apple. Under the influence of testosterone, this becomes enlarged and generates the Adam's apple. The assumption is that if you push the thyroid cartilage out, you create longer vocal cords, therefore they're capable of creating deeper sounds. Longer cord, if you loosen them, create deeper sounds, hence the difference in male-female voices. So this is the thyroid cartilage both here and here. The cricoid cartilage is the ring of cartilage that goes all the way around the base, right? So this is cricoid cartilage. The arytenoid cartilage. Arytenoid begins with an A. A is a sort of triangular shape, and so is this. Right? So there's 2 arytenoid cartilages either side. They swivel in response to muscle movement to tighten and loosen the vocal cords. And then sitting on top of both of the arytenoid cartilage is a horny-looking structure. Looks like a small candy corn. As somebody pointed out to me, and therefore these are the corniculate cartilages, these pointed pieces that sit on top of each of the arytenoid cartilages. So corniculate, arytenoid, cricoid all around the base here, and then the big pieces are the thyroid cartilage. The vocal cords are best, the vocal and vestibular folds are best seen from the sagittal point of view. As you travel down into the larynx, down towards the trachea, you get 2 lateral ridges on both sides. This first ridge is the vestibular fold, sometimes called the false vocal cords. And then the next ridge below that are the actual vocal cords. Okay? So the bottom sharper ridge vocal cords, the one above it, are the vestibular false vocal cords. The tube that connects the back end of the nasal cavity, the oral cavity, and the top of the larynx. Okay, it's that tube that you breathe air in, and sometimes your food and your drink will go in there too. But they're all interconnected. That's why if you're gross like me and your nose is runny, you've got a cold, you can and spit it out. Or you can sometimes see those magicians who like suck spaghetti up through their nose and pull it out of their mouth. But there's nothing magical about that. It's just, they're all interconnected. Okay. So the pharynx has 3 regions named for the structure that's closest to it. Right. So this is the nasopharynx, right, from here to here, the area close to the back of the nasal cavity. The oropharynx is at the back of the mouth, and then the laryngopharynx is where the pharynx comes to the junction of the trachea and the esophagus. All right, so, I'm glad it's called the laryngopharynx and not the larynxpharynx. That would just be a bit of a tongue twister, right? So nasopharynx, oropharynx, and laryngopharynx. piece of the larynx, the top end of the larynx is the epiglottis here, and that closes over the opening to the trachea when you swallow. Okay, so you don't, so food and water doesn't go into your into your lungs. The fauces basically is the doorway from the mouth into the pharynx. Right? It's basically a gap space through which food and so on enters into the pharynx. The opening of the eustachian tube is right here, the posterior side of each of the nasal cavities on both sides. The eustachian tube from the middle ear enters in. We already talked about that last week, because surrounding the opening of the eustachian tube into the nasal cavity are what? No, it's a tonsil. Tubal tonsils, right? They're a circle of tonsils that surround the opening of the eustachian tube, hence tubal tonsil, right? Surround that area. Okay, that's pretty much the nasal, of all the cavities in your head. These two are the middle and inner ear. You don't need to worry about those, they're not nasal, paranasal sinuses. You've got 4 paranasal sinuses. You've got 2 frontal sinuses right above your brow line. You've got 2 maxillary sinuses in each of the right and left maxillary bone. So both of those are paired, and you've got 2 ethmoid sinuses, which are the green ones. Those are further back within, deep into between the orbital space. And then you've got 1 set of sphenoid sinuses. Bigger one here, we've got a small one there that was over there, we've got another one there as well that you can use to look at. The nasal cavity is this whole area right here, inside of the nostril, between the nostril and the pharynx. The pharynx is the tube that connects the back of the nasal cavity all the way down to the larynx. Okay? Pharynx, larynx. The external nares are your nostrils, that which you can stick your finger into. Okay? That's your external nare. The internal nare, I have never and don't ever plan on asking that on an exam, but it's basically the exit point of the nasal cavity into the pharynx, the back of the nasal passage. The nasal septum, which you can't see in the sagittal view because it would have been sliced through or slightly off center. The nasal septum continues all the way from here, separating your nose and your nasal cavity from right to left side. As you enter deeper into your nasal cavity, the ethmoid bone from the top and the vomer from the bottom form the top and bottom sections of the nasal septum. Okay? So that would divide the cell, or the nasal cavity, into front and back. The nasal conchae then are these outward folds of the lateral wall of the nasal cavity. Okay? These bumps, these ridges that you see on the lateral side. So there's going to be ridges on this side and also ridges on this side. Those are the conchae. There's 3 of them. There's a superior one, a middle one, and an inferior one. Pretty easy to remember. The grooves between those conchae are the meatuses, the nasal meatuses. The palate then is the structure that separates the bottom of the nasal cavity from the top of the oral cavity. So we have a hard palate and a soft palate. So the palate separates the nose from the mouth. People who have cleft palate syndrome, the 2 maxillary bones haven't come together and formed a suture line, so there's no separation between the oral and the nasal cavity. That's what cleft palate refers to. And then at the very top of the olfactory, or of the nasal cavity, is the olfactory epithelium. That's where you find all of the scent receptors of the nose. The ethmoid bone is up here. There's lots of little holes in the ethmoid bone, and all the neurons from the olfactory receptors pass up through there into the brain.